Hey guys, here is how you can simplify radical expressions. The deal is that if you are given like the square root of 36, okay, they're asking you what times what gives you 36. And so you can answer, well, the answer to this is 6 because 6 times 6 gives us 36. The same way you could answer the question, what is the square root of 121? The answer to that would be 11 because 11 times 11 is 121. Well, we are asked to simplify these radical expressions as much as we can. And so if I give you the square root of, say, 20, okay, we're looking to say, is there a perfect square that goes into this? We don't know the square root of 20, but we're looking to see, is there a perfect square from our list of perfect squares, the items that we actually know their square roots that goes into it. And so we can look at our list, and 1 doesn't really count. It doesn't help us, but 4 would be a perfect square that goes into it. And so we can write the square root of 20 as the square root of 4 times 5, because 4 times 5 makes 20. And we can further break that down to be the square root of 4 times the square root of 5. You generally put the perfect square first within this grouping. And you ask yourself, do I know the square root of 4 or do I know the square root of 5? And you should know the answer to one of those. If you don't, you pick something foolish. So you're looking for the biggest perfect square that goes into it, and then once you find it, now we say, what is the square root of 4? The answer to that is 4. And what is the square root of 5? Well, we don't know that, so we'll just leave it as the square root of 5. And you ask yourself, is there a perfect square that goes into the square root of 5 other than 1? And the answer to that is no. And so therefore, if you look at this, you can see that 2 square root of 5 is going to be the simplified version of the square root of 20. And if you pull out your graphing calculator, we can check our work and see that if you type in the square root of 20, okay, this calculator doesn't have a battery in it. So let's type in the square root of 20, and you square root it. You get 4.477, okay? And so the other way to check it would be, well, let's take the square root of 5, so 5 square rooted, and then multiply that by 2. Notice you get the exact same answer. They are equivalent. The square root of 20 is equivalent to 2 square root of 5. This is in simplified form. And so we're looking to take any radical or any square root that we've got and see, is there a way for us to simplify that? And so, they'll give us random items. Say like the square root of 80. Okay, and so we look at this and we say, well, is there a perfect square that goes into it? And we look down our list, other than 1, and we look for the very biggest one. 4 goes into it, but actually if you look at this, 16 will as well. Okay, so 16 would be the biggest perfect square that goes into it. 16 times, I believe, 5. 16 times 5 is 80, and so we can put that as our answer. These are equivalent. Again, we put the item from our list of perfect squares first. The square root of 16 times the square root of 5. The square root of 16 is 4, and 4 square root of 5 would be our simplified version. Notice when we go to do our answer, we look to say, can we simplify the square root of 5? Is there a perfect square that goes into it or not? And then also, secondarily, does 4 times the square root of 5 equal the same thing as the square root of 80? And so you can check that easily on your calculator. The square root of 80 is 8.9-ish, and so therefore, square root of 5 times that, square root of 5 times 4, oops, that doesn't work, times 4 is going to give us the exact same answer. So it must be true. You can't say the square root of 80 is equal to 17 and then it's something equals something. It needs to be equivalent. Your simplified form needs to be equivalent to what you started with. Okay, well, let's move ahead a minute. Pretend that you have the square root of 98. Okay, what perfect square goes into that? And as you look at this is the one that people struggle with. It's 49. So again, put that 49 times 2. Okay, and so you can break it up into 49 times the square root of 2. That'd be 7 square root of 2. And again, you could check that on your calculator to verify that the square root of 98 is equivalent to the square root of 2 times 7. Okay, now, of course, if I give you the square root of 17 and I ask you to simplify that, you look at it and say, is there anything on my list of perfect squares that goes into that? And the answer would be no, so this would be the simplified form of this item. I hope this helps you out a little bit, and I will do an episode in a little bit about the next simplifying radicals that have variables in them.